Sup, y'all? Came outside. What a beautiful night this is. Hope it's beautiful where you are. All right. You know what is beautiful? The fundamental theorem of calculus. Check it out. The integral from a to b of f of x dx is the antiderivative f at b minus the antiderivative f at a. All we got to do is be able to find the antiderivative and work this thing out. So it's very important that you know your derivative rules. Best way to know an antiderivative is to know your derivative rules. That doesn't make them like the easiest thing in the world to do, but it certainly makes your life easier if you know those derivative rules. So check out the integral rules you just ought to know that I posted in Classroom. All right, so we're going to check out how to use the FTC to evaluate definite integrals. I'm going to show you the notation so you get used to it. And then we're going to wrap the idea, this idea of antiderivatives, like kind of a Jeopardy version of calculus. I'm going to tell you the answer or the function that was derived, and you got to tell me the original function. So think about it as just like going backwards. So here we go. I got some examples for you. First one is going to be simple. It's going to be one that we could probably just use geometry to solve, but I'll show you how to use the fundamental theorem. So the integral from 0 to 3 of x dx, you see the picture there. Sure looks like it's a triangle that has a length of 3 and a height of 3, so an area of 3 times 3 divided by 9 halves. So let's see if we can get that same answer with the fundamental theorem of calculus. So first thing we want to do is find the antiderivative of the function. That function is called the integrand. Integrand. Ain't it grand? So what is the antiderivative of the function f? Let's see. That's kind of like power rule, right? What function's derivative is x? Well, it had to be x squared, right? But the derivative of that is 2x. So it's just going to, how about x squared over 2? This idea of the anti-power rule. Not multiplying by the exponent and subtracting 1, but doing the reverse of that. Adding 1 to the exponent and then dividing by that new exponent. So there's the antiderivative. Just pause for a second. You could have some kind of a plus c, like this the derivative of any added constant is going to be 0, but we're not going to worry about the added constant when we do a definite integral, because we will definitely be able to get an answer. That comes into play with indefinite integrals. Besides, we're taking one function here and subtracting it at somewhere else, and that added constant is just going to cancel out anyway. So we're not going to worry about that right now. So we're just going to get x squared over 2, and then the vertical line denotes that I'm going to evaluate that expression at x equals 0 and at x equals 3. So I'm just going to sub those in. 3 squared over 2 minus 0 squared over 2. And guess what? That is 9 halves. Hallelujah. Want that special. All right, moving on. We got the integral from -1 to 3 of the function 4 minus x over 3. And yet another one that we could use, trapezoid, to figure out what that area is. But we're going to use the fundamental theorem of calculus. So we got to get an antiderivative. Okay, take the integrand. What functions? That is the derivative of some function. How about the derivative of 4x would get me to 4? And again, we got a linear, so that's got to be some kind of x squared divided by 2, but was already times a third, so that's going to be divided by 6. Just think about that one. If you took the derivative of that, would you get the original integrand? Yes, that means you did it right. So we're going to put our vertical line to denote that I'm going to evaluate that expression, -1 and 3. Pop those in. 4 times 3 minus 3 squared over 6 minus, and careful, that's the quantity when I plug in -1. So 4 times -1 minus -1 squared over 6. A little bit of figure in here. 12 minus 9 6, that's 3 halves, minus, careful, -4 minus -1 squared, that's minus 1/6. So 12. Let's go back. All right, psych. How about minus 9/6 plus 4 plus a sixth? I needed to get those 6 back. So 12 and 4, that is 16. Minus 9/6, that's minus 8/6. 8/6 is 4/3. So 16 minus 4/3 is 14 2/3, which that's a mixed number. Don't like those. So 3, that 42. How about 44/3 as an answer? You can go on any kind of like Desmos or graphing calculator program or anything like that. And if you go over there and you type in int, then an integral is going to pop up, and you can just put in -1 and 3 in the function. You got to put the function in parentheses. Got to put the function in parentheses. So do that on Desmos. Dx, it's going to give you the value. So there's a really easy way to check whether you're right or not. And that would be on Desmos or any other website that calculates integrals for you. So we're going to move on. Here's another one for you. Okay, we know the story. We know we got to find an antiderivative. So we're going to do that right now. But first of all, I'm going to take a look at this and change it up. I'm going to say that is x squared minus x to the 1/2, so I can use the power rule. So that'll be x to the 3rd over 3 minus x to, let's see, add 1 would be 3/2. You can divide by 3/2 for sure, but a better way to figure that out, dividing by 3/2, same thing as multiplying by 2/3. And then we're going to evaluate that from 1 to 4, starting at 4. So here we go. 4 cubed over 3 minus 2/3 times 4 to the 3/2 minus, careful, 1 over 3 minus 2/3 is what that's 1 to any power is 1. So 64/3. 2/3, this is 8, so that's 16/3. This is going to be a -1/3, so plus 1/3. Here we go. 64, that's 65. 65 minus 16. 65. What's 65 minus 16? 65 minus 15 is, how about 49/3? I did it. Hallelujah. Hopefully that's right, man. I'd feel really bad if I screwed that up. You know what? Just you're gonna email me. You're gonna text me if I mess that up. I guarantee it's gonna happen. Eventually, at some point in the year. I always make one mistake each year, but hopefully not yet. All right, trig. Let's go. I love trig. Okay, we got a 3. We got a 3 sighting. That 3 is a common, just a constant, is what I meant to say. We can factor that thing out. So the antiderivative of the function cosine is sine. So that's going to be 3 times the sine of x. I'm going to evaluate that expression. Pi over 6 to pi over 3. So here we go. That's going to be 3 times the sine of pi over 3 minus 3 times the sine of pi over 6. Okay, you unit circle lovers out there. Sine of pi over 3. Huh? You didn't have to look it up, did you? Sine of pi over 3 is √3 over 2. Sine of pi over 6 is 1/2. So we can write this as one fraction. 3√3 minus 3 all over 2. And that is right. If you want it, that's an exact answer. If you want a decimal, you just go to decimals. But that's boring. Last one for you. Here we go. And man, I cooked up a doozy here. Okay, so we've got this integral. Sounds a little fishy here. Maybe I'd like to use my properties of definite integrals and split that sucker up. How about 3 to 4 of x minus 2 to the 4th plus the integral from 3 to 4 of 1. I know how to do that, but I could do it with that's just a rectangle, right? Base of 1, height of 1, that's going to be 1. All right, stay tuned on that one. But take a look at this bad boy over here. Man, I don't know what the antiderivative of that is. I mean, you got to multiply it out. But wait, it's a horizontal shift. That's right, I said it. It's a horizontal shift. Let's shift that puppy around. This integral would be the same as the integral from 1 to 2 of x to the 4th dx. And then I knew that other integral was just going to be 1. I didn't have to use calculus on that one, right? That's still available to you. And now I can use the fundamental theorem on that. So x to the fifth over 5 from 1 to 2. That's going to be 2 to the fifth over 5 minus a fifth. Well, that's 32. That's 31 fifths. And we're adding, what? Come on, 5. 31 fifths plus 5 fifths. 36 fifths. Guys, 365 every day of the year. The FTC, there to help when you need to evaluate definite integrals. But you got to be able to find the antiderivative. So there is that. So some simple ones coming your way. Go ahead and do those, get some practice with it. And then in the next unit, we'll work on how to find more intriguing antiderivatives. See you then. Peace.